Hello everyone, welcome back to my channel inphuseclab. Today we are going to continue our series from TryHackMe's web app pen testing, and the topic is going to be prototype pollution. If you don't know what it is, don't worry, I'll walk you through what prototype pollution is, how they work in modern web applications, and what are some risks related to prototype pollutions. After that, we're going to learn about some exploitation techniques and mitigation measures for these vulnerabilities. Without further ado, let's get started. Introduction. In a thrilling world of cybersecurity, where hackers and pen testers roam searching for vulnerabilities, prototype pollution allows bad actors to manipulate and exploit the inner work of JavaScript applications, and enables attackers to gain access to sensitive data and application backend. Why prototype pollution is most commonly discussed in the context of JavaScript, the concept can apply to any system that uses similar prototype-based inheritance model. However, JavaScript's widespread use, particularly in web development, its flexible and dynamic object model make prototype pollution a more prominent concern. In contrast, class-based inheritance languages like Java or C++ have a different model of inheritance where classes are typically static, and altering a class at runtime to affect all of its instances is not common or straightforward. Learning objectives. Through this room, you gain a comprehensive understanding of the following concept: how prototype pollution works, some of its potential risks to the web applications, some exploitation techniques and mitigation techniques. Learning prerequisites: understanding how websites work, HTTP protocols and methods, top 10 web vulnerabilities. Okay, let's get started. Essential recap. Before we jump into the advanced stuff like prototype pollution, let's first understand some basic things in JavaScript. Objects that hold information. Inheritance is like passing down traits from one object to another. Functions are like tools that can be used alone or are part of these objects. Lastly, classes in JavaScript are like blueprints that help us make similar things easily. Once we get these basics, we can explore the more complex topic of objects. In JavaScript, are like the containers that hold pieces of information. Imagine a social network profile as an object, where each profile has properties like name, age, and followers. You can represent this using the curly braces and the key value pairs. So if you take a look at this object, the user object right here, the way we know it's an object is these curly braces, and then inside these curly braces we have the key value pairs: name, age, followers, and date of birth. These are the keys, and BNS 25 200 January 1st 1990. These are the values corresponding to the keys. Right. To practice, open Chrome, right click, inspect, and then console. Open the follow window, and then we can complete this code, paste that into the console, and we can investigate the object. Let's do that. Okay, so we're going to inspect console and copy this one. Use console log to see the object. Now, if you want to see the object, you're gonna have basically the console log is the prints out the objects. It's going to show you, okay, this object has the name, age, followers, and date of birth. To access one of these properties, we can actually use console.log user. Say we want to get the name. It's going to display BNS. If we want to know the date of birth, we use console.log and user.date of birth right here, which is January 1st 1990. That's what an object in JavaScript. Classes in JavaScript, classes are like blueprints that help create multiple objects with similar structures and behaviors. With our social network example, we can use a class to define a general user and content creator. Classes provide a convenient way to organize and instantiate objects with shared characteristics. So let's take a look at this one. This is a class for user. For every user, all have common properties like name, age, followers, and date of birth. This class is specifically for content creator, which has additional information on top of name, followers, and DOB. The user class includes the date of birth as a part of its properties, and the content creator profile inherits these properties. When creating instances of these classes, we can provide the date of birth and other details. As you can see, including the date of birth enhances the user profiles with additional information. Prototype. In JavaScript, every object is linked to a prototype object, and these prototypes form a chain commonly referred to as a prototype chain. The prototype serves as a template or blueprint for objects. When you create an object using a constructor, function, or a class, JavaScript automatically sets up a link between the object and its prototype. Example, let's illustrate how prototypes work. So here we have a prototype for user greet function. Inside this prototype, we have a function called greet, which will print out the user's first name. Function the difference. Okay, let's copy this and play around in the browser, see what it is. First of all, I'm going to clear the console. I'm going to make this bigger. As you can see right here, it prints out the regular user greet function. This is what the code snippet means. First, it declares the user prototype, which can be linked to an object. Function, this is a constructor function called every time a new object is created. Inside this function, it links to the prototype we created above. So what does it mean? It means that for every object that's created, it will link to this particular function greet inside this user prototype. So you can actually call it this function. As a sample right here, you create a regular user, use it by calling this function. You have a name, followers, and date of birth. Nothing related to the greet function here. However, if you look at the user profile prototype function, it links to the user prototype, meaning this object can access the greet function. This function will print out the user's name. The difference between class and prototype. Classes and prototypes in JS are two ways to achieve a similar goal, creating objects with behaviors and characteristics. Imagine you're building models of cars. Using classes is like having a detailed blueprint for each car model you develop. You follow the blueprint exactly to create each car, and all cars from the exact blueprint are guaranteed to have the same features and behaviors. Classes in JavaScript work similarly. They provide a clear, structured way to create objects that share properties and methods, making them easy to understand and use. On the other hand, prototypes are like having a basic car model and then customizing it by adding features directly. With prototypes, you start with a simple object and add behaviors by linking it to a prototype object that already has those behaviors. Objects created this way are linked through the prototype chain, allowing them to inherit behaviors from other objects. This method is more dynamic and flexible, but can be harder to manage and understand the structural approach of classes. Inheritance. In JavaScript, it allows one object to inherit properties from others, creating a hierarchy of related objects. Continuing our social network example, let's consider a profile for the content creator. This new object can inherit properties from the general user profile, like name and followers, and add particular properties such as content and post. So this is the object, the content creator profile inheriting from user. Let the content creator profile equals to the object create the user. The content creator profile inherits properties from the user using object.create function. It has specific properties like content and post, and inherits name, age, and followers from the general user profile. Inheritance helps create a more specialized object while reusing common properties from a parent object. JavaScript supports both classes and prototype-based inheritance. In JavaScript, every object has a prototype. When you create a new object, you can specify its prototype. Objects inherit properties and methods from their prototypes. You can use the object.create method to create a new object with a specific prototype, or modify the prototype of an existing object using a prototype property. Class-based inheritance. JavaScript also supports classes, which provide a more similar syntax for defining objects and inheritance. Classes in JavaScript are syntactical sugar over JavaScript's existing prototype-based inheritance. Under the hood, classes still use prototypes. We start by defining a generic user profile object that represents common properties shared by different types of profiles, which has the email and password. In this example, user profile includes properties like email and password, which might be common to all user profiles. Create content creator profile. We create a specialized profile called the content creator profile. This profile is specific to content creators and might have additional properties or behaviors beyond those generic user profile. We achieve this by creating content creator profile using the object.create user profile, which sets the user profile as a prototype for the content creator profile. Adding additional properties. After creating content creator profile, We add specific properties such as post. This is unique to the content creator profile and is not inherited from the user profile. So user profile is a prototype of the content creator profile. Accessing the properties. When accessing the properties of content creator profile, JavaScript first checks if the property exists directly on the content creator profile. If it doesn't, it looks up the prototype chain and checks if the property exists on the user profile. If found, it returns the value from the prototype chain. So the content creator inherits properties, emails, and password from the user profile, while also having its own unique property of numbers of posts. This allows a hierarchical structure where specialized profile can inherit common properties from a generic profile, while adding their specific attributes. So let's summarize what we have discussed so far. The concept of prototypes plays crucial roles in implementing inheritance. Each object in JavaScript has a prototype, which serves as a blueprint for objects, properties, and methods. In the above image, when we define a class like user profile, its prototype becomes a prototype of all instances created from it. This means that properties and methods defined in the user profile class are accessible to all instances. Properties and methods defined in the user profile class are accessible to all instances of user profile. Additionally, JavaScript allows us to extend this prototype dynamically, enabling inheritance through prototype chaining. Subclasses like content creator, content designer, and moderator can extend the prototype of the user profile class to inherit properties. By leveraging prototypes, JavaScript provides a flexible and efficient mechanism for implementing inheritance, enabling code reuse and maintainability in object-oriented programming paradigms. So what's the default value of the age property in the user object? Is 25. What is the output once we run the regular user create after executing the prototype code snippet? It's hello Ben S. It's right here. We were talking about this right here. We can also see it right here. We copy it, we ran it, and then it shows hello Ben S. After executing the inheritance code snippet, what is the total number of user-defined properties in the content creator profile? It should be 50. After executing the inheritance code snippet, what is the total number of user-defined properties in the content creator profile? From this one, we see that the content creator profile inherits properties from the user object. And in this user object, it has 1, 2, 3, 4. It has 4 properties. So the answer should be 4. Okay. How it works. Now that we have a basic understanding of JavaScript, let's dive into the prototype solution using the same social network example. Prototype solution is a vulnerability that arises when an attacker manipulates an object's prototype, impacting all instances of the object. In JavaScript, where types facilitate inheritance, an attacker can exploit this to modify shared properties or check malicious behavior across objects. Prototype pollution might not always present a directly exploitable threat. However, its potential for harm becomes pronounced when it joins with other types of vulnerabilities, such as XSS or CSRF. A common example, let's assume we have a basic prototype for a person with an introduce method. The attacker aims to manipulate the behavior of the introduce method across all instances by altering the prototype. This is the person prototype. This is the person constructor function, and this is the code that creates a new instance. Let's copy this one. Copy the code both, paste in console, enter. Delete this one. Now we can use ben.introduce, which will print out his name. Hi, I'm Ben. What if an attacker injects malicious content into the introduce method for all instances using the proto property? In JavaScript, the proto property is a common way to access the prototype of an object, essentially pointing to the object from which it inherits properties and methods. somehow the attacker executes the code using any vector like XSS or CSRF. For those who don't know, XSS is cross-site scripting and CSRF is cross-site request forgery. So let's try that. Let's try these two. Let's call the function again. The introduce method inside the person prototype has been changed from hi, I'm, and then the user's name to you've been hacked, I'm Bob. Let's look at this if you want to access a function. Now, this is in the case that it only has one function. In many cases, in many scenarios, a prototype can contain several functions or methods. So if they have multiple methods or function, they will show up to access one of those functions or method. You can use console.log ban.proto.introduce. So basically that's what it is. So let's go over what's happening. The person prototype is initially defined with the harmless introduce method, introduce the person, object instantiation. The instance of person is created with the name ban. Let ban equals ban right here. Prototype pollution attack. The attacker injects a malicious payload into this method, changing its behavior to display harmful message. We have polluted the proto property. When an attacker runs this code, it actually changes the behaviors of the introduce function right here. This part right here accesses the introduce method inside the person prototype, and this one is this part on the right side. It rewrite the function. It rewrite the functions. Impact on existing instances. As a result, even though the existing instance ban is affected, calling ban introduce now outputs the attacker's inject message. Now, this is the inject code right here, and this is the console log, which verifies that the function or the method has been injected or has been altered. This example shows how an attacker can alter the behavior of shared method across objects, potentially causing security risk. Preventing prototype pollution involves carefully validating input and avoiding modifying prototypes with untrusted content. After executing the code, if you create a new person, let charge equal charge, what would be the output of charge introduced? It's going to be the same, because whatever object that is created by the person's name, by the person object, this person object also linked to the prototype, person prototype right here, which has been altered by the attackers. So the message is still going to be the same, which is, where is it? This one. What is the name of the property that attacker polluted? Proto. Exploitation with the XSS or cross-site scripting. Standard approach. Numerous properties are present in the object prototype in JavaScript. Among these, the constructor and the proto properties stand out as a particular notable target for exploitation by threat actors. The constructor property points to the function that constructs an object's prototype, while the proto is a reference to the prototype object that the current object directly inherits from. Malicious actors often exploit these properties to manipulate an object's prototype chain, potentially leading to prototype pollution. The golden rule. The concept hinges from the attacker's ability to influence certain key parameters, such as x and val, in expressions akin to person x, y equal vals. Suppose an attacker assigns proto to x. In that case, the attribute identified by y is universally set across all objects, sharing the same class as the object with the value denoted by val. In a more intricate scenario, when an attacker has control over x and y in a structure like person x, y, z equals val, assigning x as a constructor and y as a prototype leads to a new property z, established across all objects with the assigned val. This latter approach necessitates a more complex arrangement for objects property, making it less prevalent in practice. So what does it mean? I'm confused like you, so I used ChatGPT to look it up, and this is basically the explanation. The basic idea is objects. inherit properties from the prototype. If you modify the prototype, all objects that inherit from it will be affected. How does the attack work in the example? The person X, Y, this one is equals to what we tried earlier. So this one is actually equivalent to person.x.y, which we have used earlier in the example. If the attacker controls the X and set it to proto, then instead of setting a property on the person, they set it a prototype on all objects. In this case, X is set to proto. We have person.proto.y equal vowels. It's basically the same thing as what we did over here. Using the above example, Ben is the object, the person is the object, and it acts as the prototype that is linked to this specific object. And then Y is going to be whatever properties or method within that prototype. In this example, it's going to be introduced. And then we assign that to the val. In this case, it's going to be function, a new function the attacker tried to inject into the prototype. Basically, that's what it means. And similarly, we have person xyz equals to val, and then if x is a constructor, y is a prototype, then z is the property we try to inject into that prototype. Person x is constructor, y is a prototype, and z is the property. It can be an existing property within the object, or it can be a new property you want to add to the prototype. That's what it means. This part is a bit confusing. A few important functions. When identifying potential prototype pollution vulnerabilities, penetration testers should focus on commonly used vectors susceptible to prototype pollution. A thorough examination of how an application handles object manipulation is crucial. We will understand the important functions an attacker can exploit, and then we will practically perform the exploitation. Property definition by path. Functions set object properties based on a given path, like object ABC equals to val, can be dangerous if the path components are controlled by the user input. These functions should be inspected to ensure that they don't inadvertently modify the object's property. Consider an endpoint that allows the user to update reviews about any frame. Initial object structure. Before any updates are made, we have initial friends array containing an object representing the friend's profile. Each profile object includes properties such as ID, name, reviews, and albums. This one. Input received from the user. The user wants to add a review for the friend. They provide a payload containing the path where the review should be added, reviews.content, and the review content, which is this one. So usually it should be some kind of text like this person is great, I love this person, etc. But for attackers, they want to see if the application is vulnerable. So they try to inject some malicious script. In this case, they try to see if the application can lead to the cross-site scripting or XSS vulnerability. An attacker updates the path to target prototype reviews.content, and the values is going to be this one. This is URL encoded. Oh, this is the script encoded. This is the path values, and this is a script that's been encrypted. An attacker updates a path into the target prototype right here. We use a set function to apply the payload and add the review content to specify path within the friend's profile object. Don't worry about this. Is basically you take a look at the source code, you know what it does. From there, you can exploit the vulnerability. This is more like a white box testing. Resulting object structure. After executing the code, the friends array will be modified to include user's review. However, due to a lack of proper input validation, the review content provided by the user, the malicious script, was directly added to the profile object without proper sanitization. Instead of a regular review with some text, it actually includes a script injected by the attacker. So every time you load the page, it will run. Suppose the attacker wants to insert a malicious property into the friend's profile. They can provide a payload containing the path where the property should be added, and the value of the malicious property is true. This one is the payload and will be added to the prototype. As a result, we have something like this. These are the original properties, and this is the newly injected property by the attacker. Now, we'll see how attackers can exploit the vulnerability. Suppose you are working as a pen tester in a firm tasked to pen test a social media application. You can access the application through this URL, username bob123, which I already did right here. After logging, you see a dashboard. To identify prototype pollution, We'll explore different functionalities of the social media app, like adding albums, sending friends requests, adding reviews. Once you log in, other friends can be added to your friend list. Visit a friend's profile. Once you visit a page, you will see different options like adding review, cloning album, etc. Let's explore Submit Review feature. The Submit Review feature allows users to submit any review, which will be saved in a database. Let's explore the client-side and server-side code to analyze various exploitation possibilities. So this is a client-side. We can actually see this one view page source right here. And let's see, submit a review. Submit a review right here. This is the client-side code, which is this one right here. The client-side code takes the review as an input parameter and calls the API endpoint with a post request to add a review along with a hidden parameter of friend ID. As discussed, prototype pollution alone is rarely exploitable. Combined with other attack vectors like XSS, it can provide a better attack surface. Now let's go through the server-side code. The server-side code looks like this, which we don't have access to, but if we had, then it would be a different story, right? This code is carrying the following action. First, it validates the login user session. If not, it redirects to the login page. Then the code extracts the parameter and validates the connection between the user and the friend ID receiving the request parameter. After verifying the friend's connection, the code inserts the review to the friend's object. This is the request body right here. And this is the part where the code. So this is the part the code extracts the parameters and validates the connection between the sign-in user and the friend ID. Okay. So if a friend is found, then we continue to this step. Otherwise, it will return an error saying that the friend not found. So after verifying the friend's connection, inserts the review into the friend's object. The code uses the set function in the Lodash utility to set the value of the property at a given path of an object. It's a way to set values on objects deeply without any having to check if each level of the path exists. If a portion of the path does not exist, set will create it. So it will create it right here. This is the Lodash function. The code analysis shows that this is a prime opportunity to perform the property definition by a path attack. Moving forward, add a friend to the business profile and a simple review to see how it works. The prototype, the object, and the backend shows she's great. The content of the review, she's great. The review is successfully added. Based on the knowledge from the source code review, we prepare a payload by sending a review that triggers an alert. We know that the friends object has a reviews array. When reviews are stored, the functionality to add a review works on the friend's profile like this. So this is the code in the backend which we don't have access to. But if we do have access to, that will be convenient for us. We try to script alert. Hello world. I would say inphuseclab. What's wrong? I guess I had to use a single quotation mark. So now the script has been successfully injected into the reviews. Every time we load the page, there's going to be an alert popping up. Now, whenever someone visits the profile of the user, the SS attack will trigger. In such scenarios, the attacker can even manipulate other properties that may allow admin access, is admin, or is locked in, etc. So in this task, we learn how the attacker can launch prototype pollution and an XSS attack using the property by definition technique. In the next task, we'll continue learning some more functions. Answer the vulnerable utility that the application uses with the set function, that's Lodash. In the case of an expression like test ij, what would be the controllable parameter that might lead to the prototype pollution? That's I. A few important functions. Object recursive merge. This function involves recursively merging properties from the source object to a target object. An attacker can exploit this functionality if the merge function does not validate its input and allows merging properties into the prototype chain. Considering the same social network example, let's assume that the following code. Suppose the application has a function to merge user settings. So this is called the variable recursive merge function. An attacker sends a request with a nested object in the proto. New property values. Object clone. Cloning is a similar functionality that allows operations to copy properties from the prototype chain to another one inadvertently. Testing should ensure that these functions only clone the user-defined properties of an object and filter special keywords like proto, constructors, etc. A possible use case is that application backend clones object to create a new user profiles. Practical example. Now we'll practically see how the attacker can exploit the vulnerability. Let's explore the clone album feature. The clone album allows user to clone an album. The clone album allows user to clone an album by providing a new name. Let's explore the client-side and server-side code. This is a client-side. You can view the page source and see the client-side code takes the name as input, calls the API endpoint, clone album, and the album ID right here, which is one. As discussed in the previous task, prototype pollution alone is exploitable. However, once combined with other attack vectors like XSS, it can provide better attack surface. Now let's go through the server-side code. This is the server-side code. The servers receive a JSON object containing the album's name, copy the album that needs to be copied into another object, and change the name of the newly created by calling the merge function. Right here. We know the merge function is an ideal candidate for prototype pollution if it blindly copies all the objects and prototypes without sanitizing based on keys. We can see the merge function made by the developer lacked any such sanitization features. What if we send a request that contains protos with a new property and values mentioned below? The merge function will consider the proto as a property and call object.newProperty equals the value. By doing this, the new property is not added directly into the friend object. Instead, it's added to the new friend's object's prototype. This means that the new property is not visibly part of the friend's properties, like name, age, or etc., but still accessible. So let's try cloning the album. So we try to clone the album. We enter the name here. Clone it. On the left side, we see a new property added to the prototype, which is expected. Here we go. We got a new property on the friends object. Effect on all objects on the same type. Since friend objects share the same prototype, they are created from the same template or constructor. Adding new property to the prototype means that all friends objects now have access to the new property. It's like adding a new feature to the template. Now every object created from that template has this new feature. Observing the change, even though new property is not directly visible when you print the friend object, it is still there. You can access by calling the friend's new property, which will show test value. How new property becomes visible. When you add a property via the prototype, it doesn't exist directly on individual objects, but on the prototype. However, when you access the property of the object, JavaScript first looks for that property on the object itself. If it's not found, JavaScript looks up the prototype chain until it finds or reaches the end of the chain. Rendering on screen. In the EJS template, when you loop through the properties of a friend's object using a for loop, and display them, this loop iterates over all enumerable properties of the friend object, including the inherited from the prototype. Therefore, even though new property is not directly on the friend object, but on its prototype, it still shows up in the loop it's rendered on the screen. So basically, what we see right here is a result of the for loop right here, which iterates over all the enumerable properties of the object, including those inherited from the prototype. That's why we could see it right here on the screen. Usually, we cannot see it because it's not injected into the object, it's injected into the prototype. So to answer the following question, visit this URL to get flag. You will see the following dashboard to get a flag. Uh, Seems like the property is not added. It was added. What do you mean? Property injection exploitation. A few important functions. Object recursive merge. This function involves recursively merging properties from source objects into a target object. An attacker can exploit this functionality if the merge function does not validate its input and allows merging properties into a prototype chain. Considering the same social network example, let's assume the following code. Suppose the application has a function to merge user settings. An attacker sends a request with a nested object containing proto object clone. Object cloning is a similar functionality that allows deep clone operations to copy properties from the prototype chain to another one inadvertently. Testing should ensure that these functions only clone the user-defined properties of an object and filter special keywords like proto, constructor, etc. A possible use case is that the application backend clones object to create new user profiles. Practical example. Now we'll practically see how the attackers exploit the vulnerability. Let's explore the clone album feature. The clone album allows user to clone an album by providing a new name. Let's explore the client-side and server-side code. You can find the client-side code on the source code. No. Let's explore the client-side and the server-side code to explore virus exploitation possibilities. This is the client-side. So you may know that when you inspect the page, when you view the source code of page, you're going to see the client side. Let's see, go. This is a form right here. Notice that it calls up an API clone album and then with the provided album ID right here. The client side code takes the name as an input and call the API endpoint clone album with the album ID to clone the album. As discussed, prototype pollution alone is rarely exploitable. However, once combined with other attack vectors like XSS, it can provide a better attack surface. Now let's go through the server-side code. This is a server-side. In the above code, the server receives a JSON object containing the album's name. Copy the album that needs to be copied into another object, and change the name of the newly created copy by calling the merge function. We know that the merge function is an ideal candidate for prototype pollution. The merge function is an ideal candidate. We know that the merge function is an ideal candidate for prototype pollution if it blindly copies objects and properties without sanitizing based on keys. We can see that the merge function made by the developer. We can see that the merge function made by the developer. We can see that the merge function made by the developer lacked sanitization features. What if we send a request that contains proto with a new property and value as mentioned, which is this one? We try adding this one into the field right here. Okay, we see right here, new property hacked. The merge function will consider the proto as a property and will call the object .proto.newProperty equals to the values. By doing this, new property is not added directly into the friend object. Instead, it's added to the friend's object prototype. It means that new property is not visibly part of the friend's properties, like name, age, or etc. But it is still accessible. So let's clone the album. Okay, so we already did that. And we see that a new property is added. The effect on all objects of the same type. Since all friends objects share the same prototype, they are created from the same template or constructor. Adding new property to the prototype means that all friend objects now have access to the new property. It's like adding a new feature to the template. Now, every object created from that template has this new feature. Observing the change. Even though the new property is not directly visible when you print the friends object, it's still there. You can access it by calling the new property, which will show the test value. Let's try that. Console friends new property. Console new property. How new property becomes visible. When you add the new property via prototype, it doesn't exist directly on the individual objects, but on the prototype. However, when you access a prototype on an object, JavaScript first looks for that property on the object. If it's not found, JavaScript looks for the prototype chain until it finds it or reaches the end of the chain, rendering on the screen. So why is it that we see the new property on the screen right here? That's because in the EJS template, when you look through the properties of a friend object using the for loop, this one, and display them, this loop iterates over all enumerable properties of friend object, including those inherited from the prototype. Therefore, even though new property is not directly on the friend object, but on its prototype, it still shows up in the loop and is rendered on the screen. That's why we can see it. In this task, we have learned how to add a new property into object's prototype to pollute the overall structure. In the next task, we'll know how to crash a complete application if the developer does not take necessary measures. Okay, what did they do? Let's go back. What is the default value for the newly added new property? Yes. Which was the main reason behind the prototype pollution? Correct option only. Motion of use, no absence of sanitization. That's B. Create a new property with a name band with a default value of true. What is the flag value? So create a new prototype. The value is going to be true. No wonder I couldn't get a flag. There we go. We get a flag. Fake property added. Denial of service. Prototype pollution, a critical vulnerability in JavaScript applications, can lead to denial of service, among other severe consequences. This occurs when an attacker manipulates the prototype of a widely used object, causing the application to behave. In JavaScript, objects inherit properties and methods from the prototype. Altering this prototype impacts all objects, and altering this prototype impacts all objects shared. For example, if an attacker pollutes the object.prototype.toString method, every subsequent call to this method by any object will execute altered behavior. In a complex application where toString is frequently used, this can lead to unexpected results, potentially causing the application to malfunction. The toString method is universally used in JavaScript. It's automatically invoked in many contexts, especially when an object needs to be converted into string. If the polluted method leads to inefficient processing or an infinite loop, it can exhaust the system resources, effectively causing a DOS condition or denial of service condition. Prototype pollution can interfere with the application's business logic. Altering essential methods or properties might trigger unhandled exceptions or errors, leading to terminations of processes and services. This could render the server unresponsive, denying services to legitimate users. So now we visit its website and see if we can crash the server through any input. As discussed, we have the method object.prototype converts an object into a string data type. We visit the profile page of any friend. We can see from the previous task how the server-side code. We see this function is calling the merge function, which merges two objects. Where? What if we try to send a payload that will override our existing function like toString? And then if we call it on some object, it will cause behavior on the server. To prepare the payload, let's take a simple JSON code that will override the toString function as follows. Okay, where's the toString? Go to the profile page and enter the payload instead of the new album. Let's decode the payload once the app.js receives the request. So where's the album? Is here. So obviously we get error, type error. This creates an abrupt behavior as toString is widely used among other different objects. When we click on the clone album, the application crashes and shows the below errors. The type error we get is the object prototype string call is not a function, as we have already overwritten the function using prototype pollutions. You can override several other built-in objects, functions like toJSON, value of, constructor, etc. But the application won't crash in all behaviors. It entirely depends on the functions that you're overriding. So now we visit this website and start the server. Port 8080. What is the flag value used after crashing the server to toString? Answer the question. What is the flag value after crashing the server through toString method? Crashed. TryHackMe. Fetch. £d. After overriding the built-in function string function to locale string, what is the flag value? We're gonna have to reset the server. Visit this URL to start the server again. This is the default welcome page. How come I don't see the server again? Oh, this is localhost. Okay, I'm not sure why it's not resetting the server. Let me try to reset the machine, and after that, we're gonna be trying the toLocale string. Let's go over automating the process. Major issues during identification. Identifying prototype pollution is tricky in any language, particularly in JavaScript, because the way of JavaScript lets one object share its features with another. Detecting this problem automatically with software tools is hard because it's not straightforward like other common web security problems. Each website or application is different, and figuring out where prototype pollution might happen requires someone to look closely at the website's code, understand how it works, and see where the mistakes might be made. Unlike other security issues that can be found in looking for specific patterns or signs, finding prototype pollution needs a deep dive into the website's code by a pen tester or developer. It's all about understanding the complex ways objects in JavaScript can affect. It's about understanding the complex ways objects in JavaScript can affect each other and spotting where something might go wrong. Security tools can help point out other possible issues, but they can't catch everything. That's why having people to know how to read and analyze code carefully is so important. There are a few important scripts. Several tools and projects have been developed within the security and open source communities to aid the automations of finding prototype pollution vulnerabilities. These are the few renowned GitHub repositories that provide tools, libraries, or insight into detecting prototype pollution's vulnerabilities. Node.js Scan. This is a static security code scanner for Node.js applications. It includes checks for various security vulnerabilities, including prototype pollution. Integrating Node.js Scan into your development workflow can help automatically identify potential security issues in your codebase. Prototype Pollution Scanner is a tool designed to scan JavaScript code for prototype pollution vulnerabilities. It can be used to analyze codebases for patterns that are susceptible to pollution, helping developers address potential security issues in their applications. PP-First is another fuzzle designed to automate the process of detecting prototype pollution's vulnerabilities in web applications. By fuzzing input vectors that might interact with other object properties, PP-First can help identify points in the application that are susceptible to prototype pollution. Client-side detection by BlackFan is a focus on identifying prototype pollution vulnerabilities in client-side JavaScript. It includes examples of how prototype pollution can be exploited in browser to perform XSS attacks and other malicious activities. It's a valuable resource for understanding the impact of prototype pollution on client sides. While identifying prototype pollution, the pen tester should look for instances where user control input might influence the keys or properties being merged, defined, or cloned. Verifying the application properly sanitizes and validates such input against modifying the prototype chain is crucial in preventing prototype pollution vulnerabilities. Answer any question. answer the question. Does a better understanding of code provide better insight? Yes. Okay, let's go back to the denial of service exploitation. What we try to do is to pollute the prototype to locale string, this one. So the payload now becomes, sorry. Let me log in again. So we have Bob as username, Bob123 as a password. Nope. Let's go here and we try to clone the album. Not this one. Payload is this one. The method we want to override is locale string. And nothing happens. Something is wrong. Let's see if we can get a flag. Where was it? It was the 80 get flag. The machine is a little bit slow. Get to this one for a flag. Let's check. So here, over here, we have successfully crashed the server. Copy. Mitigation measures. Mitigating the risks associated with the prototype pollution is crucial for both pen testers and secure code developers, as the vulnerability enables the attacker to manipulate an object's prototype, potentially leading to unexpected behavior and security issues. Here are some mitigation measures for prototype pollution. For the pen tester, input fuzzing and manipulation. Interact with the user inputs extensively, especially those used to interact with prototype-based structures, and fuzz them with a variety of payload. Look for scenarios where untrusted data can lead to prototype pollution. The context analysis and payload injection. Analyze the application's code base to understand how user input are used within the prototype-based structures. Inject payloads into this context to test the prototype pollution vulnerabilities. CSP bypass and payload injection. Evaluate the effectiveness of security headers, such as the CSP, in mitigating prototype pollution. Attempt to bypass CSP restrictions and inject payloads into the manipulated dependency analysis and exploitation. Conduct analysis of third-party libraries and dependencies used by the application. Identify the outdated or vulnerable libraries that may introduce prototype pollution vulnerabilities. Exploit these vulnerabilities to manipulate the prototypes and gain unauthorized access or perform malicious actions. Use static code analysis tools to identify potential prototype pollution vulnerabilities during the development phase. These tools can provide insights into insecure coding patterns and potential security risks. Secure code developers. Avoid using the proto property as it is mostly susceptible to prototype pollution. Instead, use the object.getPrototypeOf to access the prototype of an object in a safe manner. Immutable objects. Design objects to be immutable when possible. This prevents unintended modifications, reducing vulnerabilities. Encapsulate objects and their functionalities exposing only necessary interfaces. This can help prevent unauthorized access to prototypes. Use safe defaults when creating objects. Establish a safe default values and avoid relying on user input to set prototype properties. Initialize objects securely to minimize the risk of pollution. Input sanitization. Sanitize and validate user inputs thoroughly. Be cautious when using user control data to modify objects' prototypes. Apply strict input validation practices to mitigate injection risk. Dependency management. Regularly update and monitor dependencies. Choose well-maintained libraries and frameworks, and stay informed about any security updates to patches related to prototype pollutions. Security headers. Implement security headers such as the Content Security Policy, or CSP, to control the sources from which resources can be loaded. This can help mitigate the risk of loading malicious scripts that manipulate prototypes. By combining rigorous testing practices, security coding principles, and ongoing security awareness, both pen testers and secure code developers can contribute to the effective mitigations of prototype pollution vulnerabilities in applications. Regularly update knowledge on emerging threats and vulnerabilities is essential to avoid potential risk. Answer the question, what is the name of the process that regularly scan and updates third-party libraries and dependencies? Name of the process that regularly scans and updates third-party libraries and dependencies. It's going to be dependency analysis and exploitation. Conclusion. That is for this room. We've explored the ins and outs of prototype pollution, uncovering how attackers exploit vulnerabilities to execute harmful actions like XSS, RCE, and DOS attacks. By grasping these techniques, we've stressed the significance of staying vigilant to ward off potential threats. Additionally, we've discussed practical measures to enhance security of the applications. Awareness is key to safeguarding digital applications. Stay tuned for more exciting content. That's it for today. I hope you learned a lot about prototype pollutions, how to detect and exploit these vulnerabilities in web applications, and also I hope that after this room you realize the importance of input validations and sanitizations and some of the best practices when it comes to secure coding. If you have any questions, feel free to reach out. Thank you and see you next time. Bye.